Welcome. Today we're going to be learning how to draw Lewis dot diagrams or models. What you see in front of you is a former student's paper that I scanned in so that you can see what we're going to be doing today and kind of what it looks like, kind of a model, if you will. One of the first things I want to talk about that was about the man who came up with it. He discovered covalent bonds in 1916. His name is Gilbert Newton Lewis, and he was an American chemist, and he was a professor, a longtime professor at the University of California at Berkeley. And there was some suspicion around his death, and I'll let you look it up and kind of decide for yourself what happened. But he was nominated for the Nobel Peace Prize 35 different times and never won the prize. So, like I said, we're going to be looking at what he devised and presented back in 1932. Now, Lewis structures starts with finding the element that you want to draw. So you find that first in the periodic table. The periodic table will tell you how many electrons are going to be in the outer valence. And after you've determined that, then you can start drawing it around the element itself. So let's take a look at kind of the steps. First of all, you're going to find out which column it belongs to. So if, for instance, it's in the alkalis, you know that there's only one electron in the outer valence. If it's in the alkali earth metals, that'll be 2, and so on. We're not going to concern ourselves much, though, with the metallics. The metallics are a little bit more confusing, a little more complicated, and we're going to be looking at that a little bit later. But kind of pick up where I left off. If it's in this group, it'll be 3 all the way to 8, and of course in the halogen, or excuse me, the noble gases. So depending on where the actual group or column is will determine the amount of valence electrons. So as a quick review, first thing, you know that each column represents a particular group, and that column or that group, because of the outer valence, have certain characteristics. Because of those certain characteristics, it's all determined by that outer shell or valence of electrons. And of course, that outer shell is where we're going to find the various amounts of electrons. For instance, as I said before, if it's over here, it's going to have 1 electron, and that includes hydrogen as well. And of course, all the way to the noble gases, which have 8. Now, there is one exception. Helium has 2 electrons. Everything else, as I said, is pretty true to form. So let's draw a few of them, just to give you an idea of what goes on and how you can practice this. First of all, you write down the element down, and because it's carbon, what we're going to be doing is we're going to be drawing some of the electrons around it. But I want you to pay close attention to how I draw them, because once you start a particular kind of habit, you need to continue it so you'll avoid some of the mistakes that many students make. So what I do is I put a little, like a sight, gun sight on it. And then I always start right up here, and I just start counting. This one is carbon. It has 4 electrons in the outer valence. So I go 1, 2, 3, and 4. So it looks like this. So I draw the 4 electrons in the outer valence, and that's what the Lewis structure looks like with the dots on it. So I always start like right here, and I move around in a clockwise position each and every time. So I start at number 1, move all the way around. So sounds pretty simple, doesn't it? So let's do another couple of them. For instance, hydrogen. It, of course, has 1, and lithium being an alkali. We always put the symbol of the element that goes on the top. Now, ones are pretty easy, but what about when they have more? So we're going to do nitrogen next. So nitrogen, and I'm going to draw the gun sight on here again. And you're going to go 1, 2, 3, 4, and then 5. So it looks like this. So we have 5 electrons in the outer valence, and what it also has is it has some holes or spaces that it can share an electron with. And because this is very electronegative, it wants electrons to share. So it'll take it from other places, like the alkalis or hydrogen. So it'll be more than happy to take it on because it has a higher electronegativity or affinity for electrons. So let's take a look at another one, and that's oxygen. And here's oxygen. And I'm going to draw the site again. And you do this every time, and not necessarily the site, but you draw it in the same location. I start here, 1, 2, 3, 4, 5, and 6. So again, the oxygen element is going to look like this. 2 electrons here, 2 electrons here, 2 electrons here, 1 and 1. So it has 2 spots, 1 here and 1 here, that it looking to fill its electrons, so it has a complete valence of 8. We use the octet rule, so we're trying to make sure that all of the valence is filled out with 8 electrons. So that's fairly simple, but now let's start making compounds, because when we start doing the Lewis dot structures with compounds, it gives us what the structures look like, so we can look at bond angles and some other things. So let's turn that off and let's go to the next one. So let's look at hydrogen bromide. HBr, so it looks like this, HBr. So the first thing I'm going to do is I'm going to go ahead and take hydrogen, and I'm just going to draw the dot diagram for that, and then I'm going to put bromide right up here, 1, 2, 3, 4, 5, 6, 7. So if we were to draw that, you notice right off the top that this has an empty spot for hydrogen to go to. So on this particular one, we'll draw it like this. Here's the hydrogen. It's going to rotate its electron down over here. So it goes like that. And then the bromide. Here we go, the bromide right here. And right, 1, 2, 3, 4, 5, 6, 7, and of course we have 8. So that is hydrogen bromide, and with that, it gives you kind of an idea of how everything is working. But we're not done yet. So first of all, we do all the practice stuff here. So it goes from here to here, and then I want to actually draw the bonds themselves. So as you can see up here, they're going to be sharing these bonds. So to show that that's a covalent bond, we're going to draw this bond right here, and then bromide like this, and you have to draw your electrons in the outer valence. And now everybody's satisfied with their electrons because hydrogen, it's given away its 1, and of course with the 1 that's over here, it has 1, 2, 3, 4, 5, 6, 7, 8. Everybody's happy. This is how you do or draw the structure for the Lewis structure. You can see it's relatively linear. So we got that one done. So this one gives you an idea. Fairly simple, straightforward. But not all of them are all that straightforward or simple. So let's show you another one. We're going to do N2H2, and that's this one right here. So let's do our hydrogens first. Just like that. 1 and 2, just like that. And then let's go ahead and do our nitrogens. We have 1 nitrogen right here. And again, it's 1, 2, 3, 4, 5. Remember, it's in the 5th group, so it has 5 electrons in the outer valence. Let's try the other nitrogen. 1, 2, 3, 4, 5. That one looks a little bit tougher to kind of put together. So I'm going to take it to the top here. So we're going to go right up here. And the first thing I'm going to do is going to draw the most electronegative in the center. And of course, in this particular case, that would be nitrogen. So I'm going to put both nitrogens in the center. But first of all, I want to draw the electrons. 1, 2, 3, 4, and 5. Keep in mind, I need 2 nitrogens, 2 hydrogens. Then I get my other nitrogen over here. 1 2, 3, 4, and 5. Now, a couple things I noticed right off the top. If I just put my hydrogens, just stuff them on the end of the nitrogens, that's not going to work because it's going to have some open spaces. In this particular case, it's going to be a double bond. And the way that happens is I'm going to bring this electron right up to here and rotate this electron up to there so it fills that valence. So it looks like this. I got them all here. 1, 2, 3, 4, and then 5. And then when I draw my other nitrogen right here, 1, 2, 3, I have an open space there. But again, I'm bringing this nitrogen over here, or electron over here on the nitrogen. So now that's going to make a double bond. Now what I can do is I can bring on the hydrogens over here, and they can share electrons right there. So we're still not done. We're going to bring down the model now because we have a double bond there, and we have our hydrogen on the outside, and I'm also electronegative on the inside. Double bond. And then, of course, your electrons. And that's how you do a double bond. And again, it has a linear type of bond structure. And it gives you kind of an idea what it's going to look like when it's all hooked up. So I'm not going to do the other two. I'm going to let you do those for homework. And this is also a part of your homework. You need to make sure you do a Lewis.diagram for all of those elements. I believe there's 21 in there. You need to do each and every one of them so you get good at it. And in case you were wondering, because I get a lot of requests about my dog, because you can usually hear him in the background, because when I come down to the basement to do all this stuff, he's usually hanging out somewhere, and he's right behind me. And I don't know if you can see him. If you just kind of look over my shoulder a little bit, you should be able to see him. And his name's Riker, and he's usually out here every evening that I'm producing these. So that's Riker, and hopefully you'll be able to see him up close and personal a little bit later. So this is how you do Lewis.diagrams, and I hope you will practice this and get your homework done, and we'll see you in the lab later. Thanks. Bye.